Hello everyone, welcome back to the lecture. Now we'll try to see the lift pit. Okay. Again, lift pit is very simple. So wherever you have lift, you're going to put a lift pit. So only the thing is, you'll be having a foundation. First, you'll be putting a PCC layer, then your foundation will come. And whatever your reinforcements are there, no, that has to be inserted into the foundation only. Like see, you have one column here, second column will come here. I'll do it like this. So one column you are going to put it here. Let me make it darker. Yeah, one column you are going to put here, second column will come here, third column will come here, fourth column will come here, and then this will be connected with the, exactly, it will be connected with the wall. So this will be a wall reinforcement. Okay. So whatever is a wall reinforcement, that is mentioned here, how you are supposed to put the wall reinforcement. We'll see that. Same thing, they have shown that in through a section here. That is your column, not the column. Your wall reinforcement will be like this. And this wall reinforcement will go inside the column. Wall reinforcement will go into the foundation. This is how the bars will come. This bar will come like this. Okay, great, fine. Now we'll try to understand here. It's nothing here, like here you're supposed to provide a kind of a column. So there you're supposed to provide 12 diameter. These are the 3 bar, and this 5 bar, 1, 2, 3, 4, 5. These are your 12 diameter 5 bar. So 5 plus 3 is 8 bar. Altogether, you will be providing a 12 diameter 8 bar here, and then it will be connected with the lateral ties. So this lateral ties will be connected like this. So this is one lateral tie, so it will be connected like this. Another lateral ties will be connected like this. So this is what you understand by this particular lateral ties. Which diameter? 10 diameter at 150 center to center spacing. Understood? No. In the same way, again here also same thing. So this many reinforcement you are supposed to provide. 5 and 3 is 8. So altogether 3, 3, 6 plus 2, 8. 8 diameter, 8 number of 12 diameter bar you are going to provide. And then it will be connected with the lateral ties in this direction and lateral in this direction, that is mentioned here. Same thing here also, another 4 number of 16 diameter bar you are supposed to provide here. 16 diameter 4 bar you will provide here. This is a door opening from where you will enter into the lift. And then this is one reinforcement here, another reinforcement here. This is understood. Now come to the wall reinforcement. All these are your wall main reinforcement, which will come vertically, and then this will be a horizontal reinforcement. So this is your main reinforcement, and this is a horizontal reinforcement here. So that is why it's mentioned here that your main reinforcement, whatever you have, no, this one, this is your vertical reinforcement. So vertical reinforcement, you can see the dotted bar, it's shown here. You're supposed to use a 12 diameter bar, and the center to center between two vertical will be 150. V means it's a vertical reinforcement. H means your horizontal reinforcement. So vertical will go like this, horizontal will go like this. So horizontal, you're supposed to use a 10 diameter bar, and the center to center spacing will be 150. So it's written horizontal. That's it. So whatever I explained to you in the previous video of my basement plus ground plus 3-story building, no, same lift you're supposed to give. Only the thing is here, all the 4 corners, your columns are going to come. Here also column, here also kind of column reinforcement will come. That's it. Understood, right? Fine. So this was all about the lift reinforcement. Now we'll get into the plinth, this thing. What is that? Tie beam. Tie beam and plinth beam both are same there. Okay. They are mentioned tie beam, that is fine. So for tie beam, the reinforcement, you know how to read. I'll not explain it again. Same thing here. Beam, tie beam, TB1. So you're supposed to provide a 16 diameter 4 bar at the top, then another 20 diameter 2 bar in the second layer. So all these are your 16 diameter 2 bar and 20 diameter 2 bar. So 20 diameter 2 bar will be at the outer face, and 16 diameter 2 bar will be at the inner face. This is your lateral ties, the stirrup, which you're supposed to provide 8 diameter bar at 100 mm center to center spacing. That's it. Rest all things you know to learn. You know to read. I'll not explain the same thing. Then after that, you are supposed to provide a ramp. So this is how the ramp will look. So your ramp will start somewhere from here. We can see here. So ramp is going to start here. So ramp will be something like this. Okay. So a ramp will be like this. So ramp will go like this always. Okay, ramp starts. So ramp will be, this is how the ramp will look. And for that, they have given the reinforcement here. This is a plan for the ramp. Your ramp is going to start from here. So it will go like this, and it will go up from here. Okay. So this is a ramp plan what they have given. So and then this is a staircase detail what they have given. So this is a staircase detail. This is your first flight. It will come and stop here. This is your landing level. From here, your second flight will come. Then it will come and land here. So this is about the staircase detail, what is mentioned. You know how to give the staircase reinforcement. This is your tie beam. From the tie beam, your staircase reinforcement will start, and will bend it like this and take it like this. So since it's a big staircase, we have given 2 landing. One landing is here. Next landing will come at this direction. See, one landing is this one, then another flight and another landing will come here. Got it, right? So this was about the this thing. What is that? Staircase details and the ramp details. And apart from that, yeah, that's it. Yeah, that's it. Okay, so this was all about the tie beam details, staircase details I've explained you. And yeah, everything is covered, nothing is left out. Yeah, and last we'll go to the slab details. So slab details, you see, already I've explained you many types of slabs. So here again, this is a complete slab plan, what they have given. So these are the different slab what you have. Like, see, all these are the beam layout, B1, B2, B3 and all. And everywhere the slab is given, like S1, S1, S1 is a different type of slab, one group of slab. Apart from S1, we have another group of slab, that is S2, 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 and S2. So for everything, they have mentioned it here. Like if you're using a S1 slab, the thickness should be 150. If it is S2 slab, it is 150. Then both are your two-way slab only. And then he has given along the span, you're supposed to use a 10 diameter bar at 125 center to center, alternate bars bent up. And your distribution steel or along the longer span, you're supposed to provide 10 diameter bar at 125 center to center spacing. So then he has mentioned it, your bar will go something like this. Your slab reinforcement will be starting like this. Okay, it will start like this, come like this, give a crank and take it down like this. This is one reinforcement. Next reinforcement, you start like this, bring it here, give a crank and take it like this. Next, after that, your next reinforcement will start from here. It will go like this, give a crank and take it to the next panel. And from the last panel, it will come like this, give a crank and take it here. It will come like this. Understood? No. So these things I had explained in the initial lecture that this is how the slab reinforcements are given. I'll show you one image also for that to put it in a better way. Yeah. So this is how the slab reinforcement will look. Last time I had explained you. See, this is one panel, this is second panel and third panel. So first from here, you'll start the top bar, you'll give a crank, you'll bring it like this. So this way you are going to arrange the bar. Then from here, your bar will start, you give a crank and take it here. Okay. So now what happened? This spacing is fine. This spacing is, let us say 125, 125, 125, 125. So one panel I finished. I'll go to the second panel now. So since you have stopped the bar here, from the top of this bar, I'll start my next bar. So it will go like this. My crank will start from here, bring it down and take it like this. Now this spacing is doubled, so I need to decrease the spacing. So I'll start another bar from this direction. So my bar will start from here, give a crank and take it to the top. So this is 125, 125, 125, 125, 125 spacing. Then again from here, since this is bottom bar, from here I'll start my next bar, give a crank like this and take it here. Okay, this crank should have come little on this side, but it's okay, no problem. Somewhere it should have extended, it's okay. Then next bar I'll start from here and give it. So this is how, this is called as alternate bent up bar. Okay, giving an alternate bent up. Now one bent up is here, coming, you're giving a crank, you're going to bring it here. Next, you're starting from here. So alternate bent up, alternate crank, both are one and the same. Few people call this as bent up bar. Few people call this as a crank bar. The meaning is same. Okay, understood, right? So this is how the reinforcement are supposed to be provided on the on that particular slab, and that is what it is mentioned here. So 10 diameter at 125, you're supposed to provide. Wherever you have S2 slab, there you're supposed to provide 10 diameter, 100 mm center to center spacing. Same thing, you can see it here. Only the difference, sometimes what people do, see, in my slab, I haven't given this bend here. If you observe it carefully, I haven't given this bend here. But usually this bar should be bent like this. It has to give a small bend and it has to bend like this. Okay, it has to start like this. It has to get a bend like this and start. But I didn't give that. But practically, that is how you're supposed to give. And how much should be this bend? This small bend, what you have done? No, it should be 8 times the diameter of the bar. Few people keep it as 9 times the diameter of the bar also. Here he has mentioned that this particular bend, what you're doing, this one. It has to be 9 times the diameter of the bar. Suppose if you're using a, let us say, 10 diameter bar. So 10 into 9 is 90. So this bend, you have to keep 90 mm. So practically, this is how you're supposed to do it on the side. Okay. And then all these things is mentioned, which is already covered in my lectures, that what is L/7, where you have to do L/5. Okay. So try to go through this just in case if you're not able to follow anything. If you feel like you haven't understood so far, I already told you many number of times. This will be my WhatsApp number. Okay, you have to WhatsApp me. I'll be there to explain you. If you can't WhatsApp, just mail me on 𝗙𝗏𝗂𝗏73@gmail.com. So I'll be there to help you out. See, my intention is very simple. Whatever I'm teaching, you should be in a position to understand. So again, all the things I'm not explaining every time because already these things are covered in my previous lectures and all. So if you have that understanding, you can easily understand this. In spite of that also, if you feel no, sir, previously I would explain, but still my doubt is there. I did not understand this. Always you WhatsApp me on this number. I'll explain you through WhatsApp or I'll come on Zoom, and on Zoom I'll directly come one-to-one live, and I'll be there to explain you these things which you are not understood. But you have to understand that is my intention. Even if you ask me 100 times, it's okay, no issues. But you should understand all these things. Okay, that's it. So that is why again I'm not explaining all these things. Okay, that's it. And then he has mentioned that whatever cover block you are keeping, see, this is cover block. Cover block from the slab to be placed at every 375 mm center to center, starting at 300 from the edge. That means, see, usually cover block we randomly keep it. We make sure that none of the reinforcement is touching the this thing, slab centering. So there is no certain rules that what spacing you're supposed to keep. But here he has told that the center to center distance between your cover block should be 375. And the first cover block what you're keeping from the face, from the face of this beam support should be at 300. Okay. So it's trying to tell that this should be minimum 300 mm. Not minimum, maximum it has to be 300 mm. Okay. The first cover block what you're keeping from the face of this beam should be 300 mm, starting 300 mm, not more than that. Minimum, yeah, max to max, you can keep at 300. Okay, not more than that. Yeah, understood, right? Yeah. So I hope you have enjoyed this lecture up to here. You have got an idea like how to understand the slab reinforcement and all. Almost everything I have covered here. Again, I'll repeat the same thing. In spite of that, still, if you have any doubt, you can always get back to me. Huh? One last thing we'll try to understand. See, here he has mentioned for all the cantilever beam, top reinforcement should be anchored in back beam by 1.5 into length of the cantilever beam. What is trying to tell? He's trying to tell that, see, this particular beam is my cantilever beam. I'll draw it. This particular is my cantilever beam. So in the cantilever beam, whenever you are providing a reinforcement, where you will provide cantilever reinforcement, it will be a top reinforcement. Since your tension will be at the top, this bar, you cannot stop here. You have to take back side, this bar has to be taken sufficiently back. How much back you are supposed to take from the face of this beam? You have to give at least 1.5 times the L. Now, what is L? L is your length of this cantilever beam. So let us say the length of your cantilever beam is 2700. You do the calculation. The calculation is 2.7 into 1.5. 1.5 times the L. No, try to do the calculation. Tell me what answer you are getting. So 1.5 into 2.7, 4.05. So 4.05 meter you have to back anchor your reinforcement. So this cantilever reinforcement should have a continuous from here. From here you will start the bar. So this will be a top reinforcement. But from the face of this beam, it has to go up to 4.05 meter. So it's written here should be back anchored in back beam by 1.5 times the length of the cantilever beam. Why it has to be done? Again, for a very same reason. Since it's a cantilever beam, because of the moment, because the force is going to come, we'll have a UDL coming on this. So this UDL will try to have a moment here. So it will try to bend this cantilever beam. So whenever it's trying to bend this cantilever beam, backside I should have enough support so that it will not fall. Suppose if I don't have the proper back support, what will happen? This may try to fall. Okay. So this thing was explained in my site engineer course that I had taken an example of this thing. What is that? Eraser and a scale, and I'd explain you that. For example, let us consider that how shall I do that? Yeah. Suppose let us say this is my column. Okay. And on this column, I'm giving a this thing. I'm keeping one scale. I'm keeping a scale like this. Okay. So this is a scale what I have. Yeah. So now let us say on this I'm keeping some weight. So this is a weight what I have. This is a weight what I have. It is applying a weight. So now what will happen? This length, whatever I have, no, this length is more, and this length is small length. So what will happen? And let us say this particular force is P force. So this P force will try to rotate because it is getting a length from here. So this P force, this is a P force. This P into this distance I'll consider to be L. So this P will try to rotate like this. So P into L, the moment is created. So whatever moment is created, that much resistance from here it has to offer. This much resistance. So let us say this particular length is L dash. Okay. So whatever is the unit weight of this particular beam, no, that unit weight has to resist this much amount of moment. So this is my restoring moment, or this is my resisting moment. So this resisting moment should be more than this moment. Okay. If it is not more, then this will try to topple like this. It will try to overturn. So that is why what we are supposed to do, we have to keep our reinforcement in such a way that this back anchorage should have enough length. If it has enough length in backside, then what will happen? It will have more area of concrete, or I mean, it has more area now here, and this length also is increased now. This length is also increased from here to here. So whatever moment it is trying to create, this resisting moment will be more than that. Okay, whatever moment is getting created from here, more moment is getting created from here. So what will happen? It will have a balance. It will not try to overturn. That is why this back anchorage is required. Okay, so that is how it is. So I hope you have enjoyed the lecture up to here. You got an idea regarding the back anchorage length. Nothing, just you have to increase the reinforcement. Anyhow, it will have a continuity in the back support. So it will not affect much. Only the thing is the reinforcement what you're developing in your cantilever beam, no? This reinforcement what you're developing, it has to go enough back. I mean, it has to go backside. This reinforcement what you're developing, you should not stop your cantilever reinforcement like this. You have to extend your cantilever reinforcement up to 1.5 times the L. That's it. Up to here, you have to develop. That's it. That's the main intention of this point. So I hope you have enjoyed my lecture up to here, and you have got an idea regarding how to understand this particular drawing, how to understand the beam details and all. Each and everything I've covered it here. And this is the last level. It's a MUMT level, or it's a slab plan. Last level, it's a plan what I have. There the slab thickness is 150 and the reinforcement is given, which you already know. Nothing much in that. So this way we have finished the entire structural drawing part. All these things is covered. These things also I have covered. Nothing is left at. Last one more point is there. This thing I will cover. Yeah, we'll try to understand this thing. So here it's written typical details of a hanger bar below the secondary beam resting on the main beam. Yeah, we'll do one thing. This thing I'll cover it in the next lecture. This thing and this thing I'll cover it in the next lecture. And then we'll try to understand a few this thing, structural steel drawing. Okay. So I don't know, I don't have much knowledge about the structural steel, but whatever basic knowledge I have now, I'll be explaining you in the next lecture. Next lecture, I'll start from this point. It's a very important point which we need to understand. So I'll see you back in the next lecture. Thank you.